Hello all. We are going to be going through the section on exponential and logarithmic equations this time. We're going to take some stuff out, and there are a few problems that I'm not going to go through completely to solve, because once we get down to the equation, it's quadratic or something like that, that it'll just take extra time in the video so you can solve them on your own. So, an exponential equation, as we have talked previously, is an equation where the variable is an exponent. So exponential equations, just like that whole last unit we did, and some parts of this unit. This next part here, we're actually going to cross this off. There are two different strategies to solving logs, and this one that we're crossing off works some of the time. The one we're going to go through works all of the time, no matter what. So we're actually going to cross off this first sentence here as well. And the second sentence. All the way up to, instead we will use logarithms. I know how those logs just make you smile, so we are going to go ahead and learn how to use logs to solve exponential equations that are a little tougher. So, what you want to do here is, once you have two things equal like this, you can actually take the log of both sides. So you have log of 4 to the 3x equals log of 8 to the x plus 1. And I'm going to go ahead and put that in parentheses. If you'll remember, this is actually log base 10, but I'm not going to write it in because your calculator does that automatically. So I won't write that in anymore, just so you remember we're doing log base 10. And now we can use some of those rules we used before. So this 3x and this x plus 1 are exponents, and if you remember the power rule, we can bring those to be down in front. So we're going to have 3x log of 4 equals x plus 1 log of 8. Now this is the part that you're not going to be super happy about, but that's okay. I'm over it, you'll get over it, it's going to be great. The logs, this log right here and this log right here, are actually numbers. If you put log of 4 in your calculator, let me grab my calculator here. If I put log of 4 in, it gives me a number value. It gives me the number 0.60205999913. And I'm going to have 3x times that out in front. On the other side, we have our x plus 1, and I can put log 8 in my calculator. That will actually give me a number also. So if I push log 8 in my calculator, I end up with 0.903089987. So now you actually have, even though it looks kind of complicated, you just have a regular equation. Over here, you can multiply 3 times this number, and you'll end up with 3 times that, and you'll end up with 1.806179974. And again, we have our x on the end there. Equals. Now on the other side, we have to do a little bit of distributing. So you take this whole thing here, and you're going to distribute it. So we end up with, and it's going to be kind of a long part here, but it's 9030899987x plus, if we multiply times 1, we'll have 0.9030899987. So all I did was distribute that out, and again, it's just a number. It's a long decimal, but it's still just a number. The next thing you want to do to solve this, it's actually only a two-step equation now. So we're going to subtract this 0.9030899987x from both sides to get all the variables on the same side. And what we will end up with, if I subtract that, is 0.903089987x. And that's equal to the other piece that we're just going to bring straight down, which is 0.903089987. And then the last step is to just divide both sides. And when you do that, this side will cancel out. You'll be left with just your x. So I will be left with x equals, and on this side here, it's the exact same thing being divided, so it's actually x equals 1, which is your final answer. One note that I would like you to make in here is use the whole decimal. If you try and cut it down and make it shorter, you're going to end up with the wrong answer because you're rounding too early. You can't round until the very end. And in this case, we didn't have to round anything at all because it came out to be a whole number. So make sure you use the whole decimal. Looking at the next example quickly. We're going to do something very similar. This time, however, you'll notice that we have a plus 4 on the end here. So the first step, instead of taking the logs right away, is you want to take and subtract 4 from both sides. So now we have 10 to the 2x minus 3 equals 17. And from there, we can take the log of both sides. So we're going to have log of 10 to the 2x minus 3. Go ahead and put that in parentheses, equals log of 17. That power rule again says we can take this and pull it down in front. So we now have 2x minus 3 times log of 10 equals log of 17. And now I'm going to go ahead and put both of those into the calculator to see what I get. And it actually turns out that when you put log of 10 into your calculator, you get 1. So this is 2x minus 3 all times 1 equals, now log of 17 isn't quite as nice. That gives us 1.230448921. So it's a long number again, but at least one side was easier. If we distribute over here, we end up with just 2x minus 3 equals 1.230448921. And now I'm going to go ahead and just solve this like a normal equation where I would add 3. And then I'd have 2x equals this whole decimal. I'm not going to waste time writing it all out again. And I would divide by 2 to get my final answer, which ends up being x equals about 2.12. That one you do have to round because it comes out as a crazy long decimal still. But you don't do that until the very end. So make a note. Don't round until the very end. Put an exclamation point on that one. Because if you round prior to the end, you will end up with an incorrectly rounded answer. This third example we're actually going to go over in class tomorrow. It is a little bit different because you have a base e here, so you want to do something a little different to solve it, which not really a big deal at all. So, logarithmic equations, let me get rid of this here. Logarithmic equations can have logs on one or both sides. In either case, you must always be sure the first thing you do is condense into one log whenever you can. So for example, this ln of x here, sure, we could take numbers and we could do some other stuff with that, but it's going to get really complicated. So we want to use those logarithmic rules to condense this down. And we know that this subtraction here, if we look at the quotient rule, means subtraction turns into division. So if we put both of these together, it'll actually be ln of 12 over x equals ln of 3. And like we talked about the other day, when you have a log on both sides that has the same base, so ln both have the same base, you can go ahead and drop the logs. So you end up with just 12 over x equals 3. We could do a little bit of cross multiplizzle there, and you end up with 3x equals 12. Divide by your 3, and your final answer is x equals 4. So this is where you drop the logs whenever you have a log on both sides with the same base. Let's look at the next one. Actually, we'll do this one in class tomorrow as well. So example 3. We want to do something very similar to what we just did. So again, we have two logs on one side, so we need to condense those down. Well, if you look at what's in between here, you'll notice that that is a plus sign. Well, if you're adding two logs with the same base, it means that you could turn it into multiplication. So this is going to be log of x minus 1 times 2x minus 3 equals 1. Now, you'll notice that there's no log over here on this side. So we can't drop the log. If we can't drop a log on both sides, you can't drop any logs at all. I know it's inappropriate, it sounds constipated, but that's what you have to do. So instead, if we recall, this log is a base 10, so we want to go ahead and use our ben. Use the log for b and e to switch this over. And this whole part here stays together. So we know that our base here is 10. N is actually going to be x minus 1, 2x minus 3, the whole thing. And our exponent is going to be 1. So when we switch forms here, I got to move over, we will end up with 10 to the first power equals x minus 1 times 2x minus 3. So we would have to go ahead and FOIL this out. So you'll have 10 equals 2x squared minus 2x minus 3x plus 3. Or 10 equals 2x squared minus 5x plus 3. I'm not going to finish that one just because it's something that you should have a handle on, where you would subtract 10 from both sides, and then you would have to factor t-bar it once you are done with that. So if you want to go ahead and give that a whirl, I will have the answers on the board for you when you come into class tomorrow. This last example is probably the trickiest one because it doesn't work out very nicely. But you will follow the same procedures that you did for the last couple. Right away you notice that there's two logs over here, but no logs over here. That should tell you right away you're going to be using your Ben rule. But before we get to that, let's go ahead and look at what we can do to simplify this down. I notice there's a coefficient on this, so if I use the power rule backwards, I pull it up into an exponent. So I'll have log base 2 of x squared. And now if you notice right here, this is where I was saying you need to be careful with how you write things, because now there's 3 different levels there. And if you're not careful about how big and small and your placement of the numbers, it's going to get confusing. And then it's going to be minus log base 2 of x minus 1. The next thing you'll see is that we have subtraction in the middle, which means using our quotient rule we can turn this into, this should have an equals 3 on the end, log base 2 of x squared, which is the first one. Subtraction turns into division, and we have x minus 1 on the bottom. And that equals 3. Remember, this whole thing goes together here. So if we use Ben, we know that our base is 2. Our exponent is 3. And the number is that whole thing, which is x squared over x minus 1. So when we switch forms, we end up with 2 to the third power equals x squared over x minus 1. 2 to the third power is 8. And then we can do a little more of the cross multiplizzle. I'm going to have to come up here. So I have 8 times x minus 1 equals x squared. Distribute. And then move everything over to the other side. So I'll have x squared minus 8x plus 1 equals 0. And right away, if you look at this, you have a 1 here. The only factors of 1 that are possible if you were trying to factor this would be 1 and 1. And there's no way in heck that that is going to turn into an 8. You can't get a 1 and a 1 to be an 8. So, your only option for this is going to be either to complete the square or use the quadratic formula, which I am not going to go through right now because it'll just take more time, and this video is already plenty long enough. So what I would like you to do is try setting up the quadratic formula or completing the square here. We'll go over all of these answers in class tomorrow to make sure that you got the gist of it. Other than that, I will see you in the morning. Have a great day.